Hi guys, today is the 31st of December. I hope 2021 is great and I wish you all a very happy and prosperous new year. So in today's video, I'm going to be talking about when to use what test. In our earlier videos, we've seen that a t-test is used to compare the averages of two different groups of a categorical variable, and an ANOVA is used to compare the means of multiple groups in a categorical variable. We have sample data here, and average height is a continuous variable. We have gender, which is a binomial categorical variable. We have age, which is a continuous variable again, and we have hair color. So I'm going to talk about how to see if there is any relationship amongst these four variables. We already know that a t-test and an ANOVA are used to see the relationship between a continuous and a categorical variable. If you guys remember, the hypothesis test statement for that was the means of the two groups are same or the means of the two groups are different. And for an ANOVA, the mean of each group is the same or the mean of at least one group is different. So that essentially means we are seeing the relationship between a continuous and a categorical variable. What if we want to see the relationship between two continuous or two numerical variables like age and average height? To do that, we have two tests. The first one is called Pearson test. A Pearson test is used to see if there is any relationship between two continuous or two numerical variables. To do that, we calculate something called a Pearson coefficient. And this value for a Pearson coefficient ranges from -1 to +1. If the value of the coefficient is -1, it means that those two variables have complete inverse relationship. That is, if one increases, the other decreases. And if the value is +1, it means that they have a positive relationship. That is, if one value increases, the other value also increases. Like if age increases, the average height also increases. And if the value is 0, it means that they have no relationship at all. It means that the data is scattered and that you can't really come up with a line equation to show a relationship between those two variables. The value typically ranges from 0 to 1 for a positive relationship, somewhere like 0.5 or 0.7. It's almost never completely +1 and it's almost never -1. If it is, it means that all the data points are exactly on a straight line. And if the value is from 0 to -1, somewhere in between, it means that they have an inverse relationship. And if it is 0, it means that there is no relationship between those two variables whatsoever. So they are just random, and you can't say that, as age increases, the average height also increases. The problem with Pearson coefficient is that it is only able to capture a linear relationship between the variables. And if we want to see if there is any non-linear relationship between the two numerical variables, we use something called a Spearman coefficient. Mathematically, it uses the similar formula except with ranks. That way it's able to overcome the linearity and able to see non-linear relationships, but we're not going to go into the math of that. So to see if there is any non-linear relationship between two numerical variables, we use a Spearman coefficient. Similar to Pearson coefficient, even this coefficient value ranges from -1 to +1. -1 indicating inverse relationship and +1 indicating a positive relationship, and 0 indicating no relationship between the two numerical variables. So we've seen how to find a relationship between a numerical and categorical variable, a numerical and a numerical variable. And to see the relationship between a categorical and a categorical variable, say we want to see if gender is somehow related to the hair color. To do that, we use something called the chi-square test, and chi-square coefficient is again used to see if the relationship between those two categorical variables is inverse or positive. So in a nutshell, these are the techniques we use to see the relationship between any two variables. So that's it for today, folks. Thank you so much.